This is the final demo on our final project for the data engineering class. My group members are Athena, Minjong, Dorothy, and I. Our topic is on ticket price prediction, which we found is very helpful and potentially can make an impact to everyone around the world. Our motivation to this project is that we want to assist people to make better traveling plans throughout the year, because flight ticket prices usually fluctuate a lot and can be very difficult to guess. We want to make an airplane ticket price forecasting model depending on numerous variables that could correlate it to ticket prices, such as origin, destination, airline company, and so on. Our target audience are everyone who plans to travel, and the final product of our project is a prediction system that will allow users to input information and output ticket prices for users themselves to compare. Users can access our product through a link from our website, and users can find other useful information from the website.
Let me introduce our product and website. The website is structured as follows. About describes our motivations and goals for this project. There is also an introduction to the course behind this project and descriptions of the techniques we used. Product includes the product we developed. You can access the product by clicking the link in step 1. There is a description of the variables you will input and detailed guidelines on how to use the product. You can enter the quarter, origin, destination, number of tickets, and airline you wish to travel. Then the model we built will use this input to predict how much the ticket will cost and show it to you. A detailed demo will be shown a little later. And methods list all the methods we used while working on this project. We used the dataset for 2018 US domestic flights obtained from Kaggle. A linear regression model was used to predict the ticket value. We used Amazon SageMaker Studio for model training and developing, and we used the pre-built sklearn to fit the training data. Then we evaluated the training accuracy and testing accuracy of the model through the sklearn pre-built score function. And for model deployment, we also used Amazon SageMaker. Contact Us contains our team members' emails and GitHub. If you have any question about this project, please feel free to contact our members.
Okay, so I'll walk through the technical flowchart for our project. First of all, we get the dataset from Kaggle and stored it on the AWS S3 bucket. Then on Amazon SageMaker, we performed data pre-processing on numeric and categorical variables in our dataset and built a linear regression model, and also went through the model validation part. The preprocessor and the trained model are exported to another S3 bucket for the later use of the fast API. For the final deliverables, we built a website for the users, which Minjun just showed us, and users will be able to access the link of the final prediction tool, which is built on Fast API. The Fast API is hosted on AWS EC2 instance, and it will invoke the preprocessor and the model from the S3 bucket, and then take the user input to run a price prediction. The output will be returned back to the user through the Fast API page within seconds.
Okay, so now let me show you the AWS tools that we use to construct this project. So let's start by we downloaded our data from this from Kaggle website, and after extracting the data, we placed it in the Amazon S3 bucket. So S3 bucket is really helpful because our data set is relatively large, but it allows us to store it over here, and then it grants easy access later on when we're trying to work on SageMaker or the Cloud9. So now we have the data, then we can start working on building the model and cleaning the data. So we use SageMaker Studio to build our model. We imported the data from S3, and then we created a bucket with code that's named airplane ticket model that will store our preprocessor and model later on. So taking all of these, we selected the data, the columns that we're going to use, and then we performed pre-processing of the data, feature engineering, and we saved the preprocessor using Pickle and then dumped it into the S3 bucket. And a similar procedure was performed on this linear regression model, where after it's being fitted, then it's been dumped to our S3 bucket. So now if we go back to Amazon S3, we can actually see that the models are being saved. And this is a great thing because later we can use it in our FAST API. So now going back to FAST API, we actually developed it using the Cloud9 programming environment. So where we developed the API, we tested it, and then moreover, we built like a homepage or dashboard setting for it so that it will look more professional. And running it will be really simple. We're simply typing python main.py. Then you can access the API within a click, or you can access it through our website. And this is exactly what you saw earlier in the presentation. And this will function as like how it was demonstrated beforehand. And so this is only part of the component of the of our entire project. The other component is the website, which provides a lot of information about our product. So that's hosted in a separate directory where everything is coded in either HTML or CSS. And if you're interested, you feel free to visit our source code. And all the source code for building the FAST API and then building our models are also located in our GitHub repository, which feel free to visit and look at our source code.